sums and differences of rational expressions. So last time we did multiplying and dividing rational expressions. Today we'll do sums and differences. And I guess what we better do first is to review how to add and subtract fractions, since rational expressions are all about fractions. So, boy, you've ever done a lot of fractions in your life. Basically, if you have one fraction of the form a over b, and you add another fraction, which is c over b, first of all, you'd be absolutely delighted because you have the same denominator. How would you add them? You'd keep the denominator the same, and you'd just add the top, a plus c, right? How about if you were subtracting? If it was a over b, take away c over b, well, it's exactly the same thing. The denominator stays the same, and this time you subtract the numerators. You know this. The point I'm trying to make here, and you must remember, is that you must find a lowest common denominator. You didn't need one when you multiply and divide. That's why we did multiplying and dividing first in this course. It's easier. Now you have to find a lowest common denominator. It's a drag, people, but you got to do it. Oh, big book club update. Okay, so let's do some questions, and these first two are exciting because they have the same denominator. It's great. If they have the same denominator, you know that in your answer you're going to have a denominator of x. It's going to stay exactly the same. And then all you do is you add the numerators together. So you're going to add together x squared plus 4. I'm going to put it in brackets. You're going to add to that 2x plus 3. Now you might say to yourself, why is he bothering to put it in brackets? It just makes it look more confusing. It probably does make it a little more confusing in this question. It's going to help us in the next question when it's a subtraction question. Anyway, what we do now is we look at the numerator and we see if we can combine anything. Is there any like terms? Are there any other x squareds? No, so we can't add that to anything. So x squared. Let's do our x's next. Here's an x. Any other x's? No, so we just have plus 2x. Then we have a few constants. We have plus 4, we also have plus 3. Add those together and you get plus 7. Denominator stays the same. Okay, if you look at that numerator, hopefully you notice something. What's that look a little bit like? Looks like it's a trinomial. Looks like a simple trinomial you might be able to factor. You should try. So what would you be looking for here? You'd be looking for two numbers that multiply to 7 and add to 2. Well, the only numbers that multiply to 7 are 1 and 7. Do those add to 2? No. So you cannot factor that. So you're done. That's it. But it's good to notice, because if you could factor it, you probably should. Alright, the last thing maybe we should add here is our non-permissible values. So if we look at our denominators here, what can x not equal? Well, x obviously can't equal 0. Our denominator would be 0, and you can't have that. So that is the final answer. I think in this chapter, much of this chapter, the book actually doesn't ask you for the non-permissible values. It just says, assume that all the x's, the variables, the unknowns, assume they're all positive numbers or non-negative numbers, I suppose. But still, I think it's good. I'm going to do all the non-permissible values in today's video because you should know it anyway. Okay, the second one, you still have the same common denominator here of 2x, so it's going to stay 2x. And then all I do is subtract the numerators. So I'm going to take 3x minus 5, and I'm going to subtract, I'm going to put this in brackets, I'm going to subtract 2x plus 3. Now, be very careful. People make mistakes like this all the time. I taught this in grade 9, and still some people make mistakes. What they do is they go, okay, this is 3x, take away 2x, and then they say negative 5 plus 3. That's wrong. This minus sign refers to everything inside. What you might want to do, like I taught you back in grade 9, is to keep the first polynomial, the binomial here, keep that binomial the same, change it to an adding question, and change every sign in here, including the first one. So 2x becomes negative 2x, and plus 3 becomes minus 3. You don't have to do that, but make sure that this minus sign right here refers to everything. This is why I put the brackets, because otherwise what happens is people don't put the brackets, and they end up with something like this. 3x minus 5, take away 2x plus 3, and now you are in trouble, because you're probably going to do negative 5 plus 3, and that's wrong. Okay, so either use the brackets like I did here, or do this opposite operation thing like I did here, or do both, and you'll be safe. Alright, let's finish this off. X's. We have 3x plus negative 2x. Well, that just leaves us with 1x, or x. And then I have negative 5, negative 5 plus negative 3. That equals negative 8. And it's still over 2x. Non-permissible value, 2 times what would make this equal 0? 2 times 0, so x cannot equal 0. All done. Well, those are great questions, but unfortunately those don't happen very often because those had common denominators. We need some steps for unlike denominators, when you have different denominators. Now, these steps are basically the same steps when you just add fractions normally, except for the first two steps here. The first step is to factor the denominators. You don't need to factor the numerator. Then you're going to determine the NPVs, the non-permissible values. You're going to determine the lowest common denominator. You're going to change the expressions so that they have the lowest common denominator. You're going to add or subtract the numerators and keep the denominator the same. And you're going to simplify the lowest terms. So let's look at this first question here. The first step is to factor the denominators. Well, both denominators are monomials. You can't factor them, so done. Second step, determine the NPVs. Okay, you must do these steps in order, by the way. So our NPVs are, what would make this first denominator equal 0? Well, two things would make it equal 0. If x was equal to 0, it wouldn't work. That would equal 0. And if y was equal to 0, it would also equal 0. So both of those. How about the second denominator? What would make that equal 0? If x was 0, and we already covered that. Okay, those are NPVs. Step 3, determine the LCD, the lowest common denominator. Okay, this is new, it's a little complicated. Lowest common denominator. So, let's pretend it's just 6 and 15. What's the lowest common denominator of 6 and 15? If you counted by 15, it would go 15, 30, 45, 60, right? If you counted by 6, it's 6, 12, 18, 24, 30. What's the first number that they both hit? They both hit 30. That's the lowest common denominator. But we also have these x's and these y's. So basically, if it's the lowest common denominator, you take the biggest exponent. So we've got x squared. The biggest is x squared. We've got y to the 1 and y to the 0, I suppose. There's no y's there. So the biggest is y to the 1. This is your lowest common denominator. You can multiply these things by something. We're going to figure out what in a second. And this is the lowest thing you can get right there. Okay, a little bit complicated, but I think once you see a few examples, you understand that. Okay, next thing we have to do is step 4, which is to change the expressions so they have the lowest common denominator. Right now, these two fractions don't have this lowest common denominator, but we want to change them so we end up with the first fraction with 30x squared y on the bottom, take away the second fraction with 30x squared y on the bottom. So we do this just like we do with normal fractions. You ask yourself, what do I have to multiply 6xy by to get 30x squared y? Well, I'd have to multiply it by 5, and I'd also have to multiply it by x. So you're going to multiply the bottom by 5x. But you know what the rule is. What you do to the bottom, you do to the top, as my grade 8s like to sing. So we also have to have 5x on the top. Great. So when we do 5x times 1, we get 5x right here. Let's do the same thing for the second fraction. We've got 15x squared here. What do we have to multiply that by to get 30x squared y? Well, we need to multiply by 2. And you'd also need to multiply by the y. What you do to the bottom, you do to the top. So multiply that by 2y as well. 2 times 2y is 4y. Great. Now we have common denominators. So the denominator is going to stay the same. And we just have to subtract the numerators. And that'll be 5x minus 4y. Don't forget your non-permissible values. And this question is done. Okay, let's do another one. First step here is to factor the denominators. They're monomials again. You can't factor. Next step, find the non-permissible values. Okay, in the first denominator, what could a not be? A could not be 0 because you're multiplying these all, and b could not be 0. Second denominator, same thing. A and b can't be 0, otherwise when you multiply you're going to get 0 on the denominator, and you can't have that. Okay, the lowest common denominator. If you look at the numbers, 2 and 9, what's the lowest common denominator of 2 and 9? If you count by 9, it goes 9, and 2 doesn't go into 9. And then 18, and 2 does go into 18. So that's what the lowest common denominator is. And the a's, you have a squared and a. Remember, if it's the lowest, you're taking the lowest common denominator, you're taking the greatest exponent. So it's going to be a squared. B, you got b to the 1 and b to the 2, or b squared, so it's b squared. There's your lowest common denominator. So what we're trying to figure out is how to change our denominators to 18a squared b squared in both cases. Let's look at the first one. What would you need to multiply 2a squared b by to get 18a squared b squared? You'd need to multiply by 9b. So we're going to multiply top and bottom by 9b. Now, when I multiply the top by 9b, it's kind of like I'm doing this. I'm multiplying 9b by all of this. So you're doing like the mountains there. Okay, so it's 9b times 2a, which is 18ab. We put it alphabetically, right? And it's 9b times positive 1, which is plus 9b. All right, the second fraction, what do you have to multiply 9ab squared by to get 18a squared b squared? You need to multiply by 2a. So we'll do the same to the top, multiply by 2a, but again, you're multiplying both things by that. So you're multiplying 2a times b, which is 2ab, and you're multiplying 2a times negative 3, which is negative 6a. Okay, be careful, there's a subtraction sign here. So I'm going to probably do one more step than you are. I can put the one denominator, obviously that's what our denominator is going to be, and I've got 18ab plus 9b. I'm going to change this to plus. Okay, I'm going to make it plus, and remember I can do that as long as I change the signs of everything here. So minus 2ab plus 6a. Now you don't have to do that. If you want, you can do, thinking of this as take away 2ab and also take away negative 6a. Okay, we're now ready to combine terms. 18ab, is there any other ab's? Yes, there's a negative 2ab. So we've got 18ab plus negative 2ab is 16ab. Then we have 9b. Is there any other b's? No, there's not. So just plus 9b. And what else do we have? We have 6a, and there's no other a, so just plus 6a. It's all over the common denominator of 18a squared b squared. Nothing we can do. If you could factor the top, you would, but you can't factor the top. And then we put our MPVs. A can't equal 0, and b can't equal 0, and we're finished. Alright, this one, finally you can factor. So let's do that first. Y squared minus 20, you can't factor. I mean, you could actually. What multiplies by itself to get y? Don't write this down, because I'm not going to do this. Y times y, right? What multiplies by itself to get 20? Well, nothing really. But if you think about it, it's a little advanced. Root 20 times root 20 actually equals 20, and then you can put the two signs are plus or minus. But you know what? We're not going to worry about doing that this year. Maybe I might ask you some bonus question or something, so there you go, a little something I've shown you. But let's not do that. You really can't, for all intents and purposes, we don't want you to factor that. Why can you factor the bottom one? What's different? What's different is that 4 is a perfect square and 20 isn't. So you can certainly factor this. What multiplies by itself to get y squared? Y and y. What multiplies by itself to get 4? 2 and 2. Make one plus, make one minus. Okay, that's the first one. Plus, well, you can't factor the y plus 2, so we just keep y plus 2 and y minus 2. We don't switch anything. Okay, that's the first step, was the factoring. Next step is to find the NPVs, the non-permissible values. Note it's easier once you've factored. We can now do this. What would make this denominator equal 0? Well, either if y plus 2 is 0, what would make y plus 2 equal 0? If y is negative 2. Or if y minus 2 is 0, this whole denominator would be 0. What would make y minus 2 equal 0? If y was positive 2. So this is another one you can just make it plus and minus 2, right? Or you can put 2 and negative 2. How about this one? What would make this one equal 0 is if y is negative 2. We've already done that. So that's it. Okay, lowest common denominator. You've got y plus 2 and y plus 2 over here as well. So y plus 2 is definitely part of the lowest common denominator. Guess what the other part is? Y minus 2. That's the lowest common denominator. Y plus 2, y minus 2. Okay, so now we want to have both of these fractions with a denominator of y plus 2, y minus 2. That's the first one, and the second one we also need y plus 2, y minus 2. Okay, well the first one's very easy. It already has y plus 2, y minus 2. So what are we doing to it? Nothing. Or if you want, you're multiplying this bottom by 1 and also the top by 1, which makes no difference. So it's still going to be y squared minus 20. However, the second one, we've only got y plus 2, and we want it to be y plus 2, y minus 2. So what do we have to multiply the denominator by? You need to multiply this by y minus 2. That'll give you this denominator. What you do to the bottom, you have to do the top. So you have to multiply this by y minus 2 as well. Okay, so this is a little bit of work here. You've got y minus 2 times another y minus 2. Let's see if we can do this in one step. A little advanced here. So this is mountains and valleys. The first thing you'd multiply is y times y, and you'd get y squared. The next thing you multiply is y times negative 2, and you'd get negative 2y. Negative 2y, just remember that. Then you'd multiply negative 2 times y, and you get another negative 2y. So we had one negative 2y and another negative 2y, which gives us negative 4y. And finally, you'd have negative 2 times negative 2, which is positive 4. If that's too confusing, then you go ahead and do all the mountains and valleys and combine terms, and you'll see you get this. Okay, good. So now we'll keep the denominator the same, y plus 2, y minus 2, and we'll combine terms. So we have a y squared here, and we also have another y squared here. How many y squareds do we have? 2 y squareds. Let's look for y's next. So the only y we have is this negative 4y. Can't combine that with anything. But the constants, we have a negative 20 here, and we have a positive 4 here. So we can combine those. We can get negative 16. Great. A lot of people stop here, but remember, if you can factor at this point, you should factor the numerator. And you can factor the numerator. How can you factor it? You can take out a 2 as the greatest common factor. That'll leave you with y squared minus 2y minus 8 all over y plus 2, y minus 2. Phew, we're done. No, we're not. Believe it or not, you can go further. Look at this trinomial here. What does that look a lot like? That looks like a simple trinomial that you could factor. I mean, we saw before you can't always factor them, but let's try it. What you'd be looking for is two numbers that multiply to 8 and subtract to 2. Multiply to 8 are only those numbers, and subtract to 2, yes, we do have a pair, so we have to factor it. So we got our two brackets. This is a simple trinomial, y and y, because that's how we get our y squared. Our numbers were 4 and 2. Big number, small number, drag down the minus sign. A negative times a what equals that negative? A negative times a positive. Don't forget that greatest common factor came along for the ride, and it's all over the same denominator of y plus 2, y minus 2. Now, what was the point of that? Why did we do all that factoring? Because look, once we've done that, you have a y plus 2 here and a y plus 2 there, and you can cancel them. So we've got a simpler answer than we had before. It's now 2 times y minus 4. You don't need to do the mountains back, just leave it like this. All over y plus 2. You're done. Let's put the MPVs down. What were they? Plus and minus 2? Yes. Y cannot equal plus and minus 2. Notice, it's good you did the MPVs before. Otherwise, you'd think the only one is negative 2. But no, it's positive 2 as well. Even though we canceled out, it's still an MPV. Wow, that's a big long one. Don't worry, this one's faster, although it's a little tricky. So, first step, we try to factor the denominators, and you can't factor them. Okay. Next thing is non-permissible values. So in the first one, what would make this equal 0? What would make it equal 0 is if m is 3, so you can't have that. Second one, what would make that equal 0? Well, it's 3. 3 minus 3 is 0, and if I put 3 in there, 3 minus 3 is 0. So in both cases, m can equal 3. Okay, lowest common denominator. What a lot of people say, better not write it down, is that the lowest common denominator is m minus 3, 3 minus times m, 3 minus m. I suppose you could get the right answer eventually doing it this way, but you're giving yourself a lot of extra work. Believe it or not, the lowest common denominator is actually that, m minus 3. Now how could that be? Well, you have to remember something we talked about before, that if you were to divide something like m minus 3 over 3 minus m, you see how they're exactly the same except they're in the different order? Remember you always got negative 1? Well, how you could turn the second one into m minus 3, you could multiply this amount right here by negative 1. I'll show you that in a second. But we can't do that to the bottom unless we also do it to the top. Remember, what you do to the bottom, you do to the top. So let's see why this works. So first of all, I'm just going to rewrite this first one. 5 over m minus 3. Plus, okay, on top, 8 times negative 1 is negative 8. Now, on the bottom, I have 3 times negative 1, which is negative 3. And I have negative m times negative 1, which is plus m. I could write it here, plus m, or I could write it here, positive m. There it is. There's a positive m. Take away 3. Do you see we now have exactly the same denominator? So a little trick there, but hopefully that makes sense. Alright, we're ready to go, and we're pretty well done because our lowest common denominator, our denominator is m minus 3. It stays the same. You just have to add these. 5 plus negative 8 is negative 3. Good. Remember, do not do this. You can't do that. If you have a binomial, and you do have a binomial on the bottom, the only way you can cancel binomial is if you have the exact same binomial on the top, and you don't. You're done, except we want you to write down your NPVs, and the NPV is m cannot equal 3. That's it. Okay? tricky section. A lot of people have a lot of troubles with this. So take it slow, don't skip steps, and think of your fraction rules, and you'll be okay.
Ain't nothing going on but history, yeah.